So in the last video, we developed the linear regression equation, and if you recall, this graph that was developed on our calculator looks similar to what we had done in the textbook. Right? These graphs look very similar. But we never actually wrote down the regression equation. So let's go back to that screen. So I'm going to press second and the mode key to go back to my previous screen, and I noticed I've erased the work that we did. So to bring up the last thing we've done on this blank screen, press the second key and the enter key. That brings back the last equation we had. And now press enter. And we're back to that screen with this y equals ax plus b. All right, so maybe we should write this down, right? Because this actually represents the line that's going through these points. So I'm going to write this equation down in the form of y equals mx plus b. So I've written the equation twice. I wrote y equals $523.56 times x plus $5,754.43. And then I also replaced the y and x with c, and oops, I wrote x here. This should be a t. T to represent the c for cost and t for number of years since 1987. So both of these I would accept, y equals mx plus b, or this c equals mt plus b. Either one of these equations would work for me. Now notice I rounded to 2 decimal places because I'm thinking about money, right? $523.56. So it seemed like going out 2 decimal places was appropriate. I believe the book actually went 3 decimal places, but that's not really a big deal. So now when we go to question number 5, right, on the next couple of pages, it says use the table feature on your calculator to find the estimated college costs given by the model for each year in the table. Okay, so I go back to my calculator, and if you press the second key, and above the graph, it says table, right? So I press second and the graph key, and then here's a table. Let's see if I can make this a little bigger. Okay, so when I look at t equals 0, even though the actual cost is $5,964, according to my model, I'm left with $5,754. And in this case, let's just round to the nearest dollar because my actual costs are all rounded to the nearest dollar. And if you look at 5 years after 1987, my costs here are $8,372, whereas my model says $8,238. So the numbers aren't exact, but they're not too far off. So let's complete this table. Okay, so you can see I've filled in my table. Again, 0 corresponds to this 5,754, that's up here. If I go down to year 9, you'll see I have 9 gives me $10,466. And you have to scroll down in the table to get years 12, 14, and 16. So I hit the down arrow a couple of times so I can see that year 12 and the year 14 and the year 16 corresponds to $14,131. So my table's complete. So let's keep answering some questions here. There is something to note here. The book talks about interpolation versus extrapolation. So any data that's contained between the 0 and 16 would be an example of interpolation. Right? It says, using the regression equation to find an output value for an input value within the interval of given data is called interpolation. So again, if I were to go back to my regression equation, and actually they show one down here, remember, t represents the input. So if I put in an input anywhere from 0 to 16, the output that I get would be an example of interpolation because it's in between my given data. If I pick a value that's outside of my table, say 17 or 18 or 19 for t, that would be an example of extrapolation because my output answer would be outside of my given data. Right? So anything that's within my table between 0 and 16 is interpolation. Anything that's outside of 16 would be extrapolation. Question 6 says, okay, estimate the average cost of tuition in 1993. So remember, 1993 is 6 years after 1987. So I'm going to place the 6 in for t and come up with an answer. So let's do that. We'll pull out our calculator. I'll press second and mode to get out of this area. And then I'll actually type in our regression equation, and I'm going to replace the t with a 6. So you can see here's my 523.561 times the 6 years for 1993 plus that 5,754 and change. So I press enter. So according to our model, the cost of tuition in 1993 should be $8,895 and some change. So I'm going to use that for my answer for 6A. So there's my estimate. Now it says by using the table on your calculator. Okay, so let's go back to our table. I press second and table is above the graph key. And if I scroll up to number 6, oops, I went one too far. You can see we have this $8,895 and they rounded to 80 cents. But if I look on the bottom of my window, you can see this 79. And you notice I have 795 here and this is 794. And that's because the book rounded to 3 decimal places, whereas my calculator doesn't round, right? I go 5, 6, 1, 3. We don't round, but the book did round to 3 decimal places. So that's the reason for the slight difference in our answers. But we're really talking about, fractions of a penny. Okay, so I'm going to write down $8,895 and I'm going to call this 80 cents. I'm going to go 2 decimal places. And there's my answer. And then part C says by using the graph of the regression equation. So it says obtain the graph of the function and then press second trace calc. So let's do that. I go back to my calculator. First I press the graph key. Right, there was our graph. Now if I press second and trace, number 1 says value, so I'll press 1. And it says, okay, when x equals, so let's put in 6, and we'll press enter. And you notice I get this $8,895. Okay, that's one way to do it. I could have really just pressed trace by itself. And notice on the top it says plot L1, L2. Well, if I press the up arrow again, now it gives me this y equals $523. Basically, it gives me my regression equation up here. Right? This equation matches what's in the book. Now, if I just press number 6, you'll see x equals 6, and I press enter, we get the same answer, right? This $8,895 and roughly 80 cents. So I'll just fill that in down here. Next, it says all of the methods support the following conclusion. The regression model estimates that the average tuition and fees at private 4-year college in 1993 was, well, again, we got the same answer 3 times, right? $8,895, and we'll call it 80 cents. So that's what I'm going to fill in down here. Okay, moving on to question number 7. Is the estimate in problem 6 an example of interpolation or extrapolation? Well, let's take a look at our table. Remember, 1993 was 6 years past 1987. And since that 6 falls in between 0 and 16, it's interpolation. So I'll type my answer in here. Part 8 says use the regression equation, table, or graph to estimate the average tuition in 2005 and 2010. So remember, 2005 is how many years past 1987? So that's 18 years. And if you remember, 2010 looks like that would be 23 years past 1987. So T would be 23. So if I were to use my calculator to answer this, I simply need to figure out what the value for y will be when x is 18 and when x is 23. So I'm going to take my calculator and I'm going to use the table method. So if I press second and graph and I scroll down to t equals 18, that will tell me the cost of tuition. There we go, 18 years after 1987. Looks like I hit the button too many times. All right, so here's 18. So in 2005, the tuition should be $15,179. And in 2010, I just have to see what happens when t or x equals 23. So I can scroll down a little bit further. and it looks like it's going to be $17,796. And I'll write that there. Let's answer the next question. Part B, it says, are these examples of interpolation or extrapolation? So again, let's take a look at our table. Our table goes from 0 to 16, and t equals 18 and 23 are outside the table. So I'm going to say this is extrapolation because the data goes outside the given table. Part C, it says, which of these two estimates do you believe to be more accurate? Interpolation is always more accurate than extrapolation, okay? So the closer you are to your given data, the more accurate your answer will be. So out of all the estimates, I would think that the estimate for t equals 6 is most accurate. And if I had to choose between t equals 18 and t equals 23, again, the 18 is closer to my given data, so I would say the t equals 18, or the estimate for 2005, would be more accurate. So here's my answer. Okay, question number 9 wants us to use the table feature of our calculator to estimate when we think tuition will hit 20,000. So if I go back to my table, right, so here's tuition at 12,000, 17,000. If I scroll down, I want to see when do I get to 20,000. Oops, there it is. So it looks like, oh, I hit the button too many times. When we get to t equals 28, that's the first time we hit 20,000. So the answer is going to fall somewhere between 27 and 28. Okay. So I'm going to support my answer. I'm going to write the one row below and above my answer. So in year 28, or really 2015 or 2015, that's the first year where my tuition will at least hit $20,000. It's actually going to be $20,414 according to my model. Okay, remember, this is your input column, number of years since 1987. This is your output column, the value of the tuition. So that concludes the lesson. One thing I would recommend you do is if we press second and mode, and then I just want to turn off my stat plot. So if you press Y equals, see how my plot 1 is highlighted? Press the up arrow, where now plot 1 is blinking. I press enter, and I press the down arrow, and I've now turned off my stat plot. And my calculator's back to the way it was when we began. Thank you.